All right, so let's get into it. Today we're looking at AI chips,
Sounds good.
and you've sent us this essay by
Oh, yeah.
Jörg-Owe.
hmm
Looks like you're interested in Nvidia GPUs,
Yeah.
Cerebras WSE3s,
hmm
and Groq LPUs.
Those are the big ones right now.
Yeah. Are you ready to unpack how these different architectures are shaping the future of AI?
Absolutely. And what's really fascinating is that we're moving beyond just raw processing power now.
Okay.
It's about designing chips specifically tailored to the way AI actually works.
So let's start with a familiar name.
Yeah.
Nvidia.
Sure.
They've been leading the pack in AI for a while now, right?
Yeah, they have been for a while.
What's made them so successful?
I think NVIDIA's strength has been in their general purpose GPUs,
Okay.
which are great at parallel processing, the kind of number crunching that AI thrives on.
Mm-hmm.
Plus, their CUDA platform gives developers the tools and language to really harness the power of these GPUs.
So CUDA
It's like a universal translator between your code and the hardware.
I see, that makes sense. So Schneppat is a big reason why NVIDIA has become the industry standard.
Yeah, I think that's a big part of it.
But Schneppat also hints at some controversy surrounding their dominance.
Mm-hmm.
What's the concern there?
Well, some argue that a company having too much control can stifle innovation.
Okay.
A closed ecosystem might limit choices for developers and potentially lead to higher costs down the line.
So it's like,
Yeah, it's like relying on a single source for all your tools. You might miss out on some specialized solutions out there.
that makes sense.
Oh?
So is that where Cerebras comes in?
Yeah, possibly.
Like WSE3 chip is a completely different beast, right?
It really is.
From what I understand.
Cerebras has gone all in on scale.
Okay.
Imagine a single chip that takes up an entire silicon wafer
Wow.
and has up to 900,000 cores.
Okay.
To put that in perspective, a high-end gaming GPU might have a few thousand cores.
Wow. Okay, that's not just a step up. That's a whole leap into a different dimension.
It is.
But why so many cores? What's the advantage there?
It's all about handling the massive amounts of data that AI models need.
Okay.
The WSE3's unique architecture minimizes bottlenecks by giving each core its own dedicated memory.
Uh-huh.
This allows it to process information incredibly quickly and efficiently, even for extremely large AI models.
So Cerebras is like the supercomputer of AI chips, built to tackle the biggest, most complex tasks.
You could say that.
But I imagine there are some drawbacks to that approach too, right?
Definitely, the sheer size of the WSE3 makes it less practical for everyday applications.
I see.
Not everyone needs that level of power, and it comes with a hefty price tag. It's a bit like using a bulldozer to plant a flower. Sometimes a smaller tool is more appropriate.
Okay, so we've got Nvidia, the versatile workhorse,
Right.
and Cerebras, the powerful giant.
Uh-huh.
What about Groq and their LPUs?
Okay.
How do they fit into this picture?
Groq is taking a more specialized route.
Okay.
They're laser focused on natural language processing, things like understanding and generating human language.
Yeah.
Their chips are designed with a software-first approach,
Huh?
meaning the hardware is built to be extremely efficient for specific language-based tasks.
So while Nvidia and Cerebras aim for broader applications,
Yeah, you could say that.
Groq is all about being the best at what they do, kind of like a master craftsman in a specific field.
Exactly. And this specialization allows them to achieve incredible speed and efficiency for those particular tasks.
Mm-hmm.
Their chips excel at inferencing, which is the process of using a trained AI model to make predictions or generate responses in real time, like with voice assistants, that need to understand and respond to your questions quickly.
So 3 different companies,
Right.
3 distinct philosophies.
Yeah.
It sounds like there's no clear winner here. It really depends on what you need the chip to do.
You've hit the nail on the head. It's not an apples-to-apples comparison. Each architecture has its strengths and weaknesses.
All right, well, let's break down those strengths and weaknesses a bit further. How do they actually stack up against each other in terms of performance?
Well, starting with Nvidia, they still dominate when it comes to parallel processing for general-purpose AI tasks.
Okay.
Their mature CUDA ecosystem and focus on metrics like GPU utilization and throughput often give them an edge.
And what about Cerebras? Does that massive scale actually translate into real-world performance gains?
It certainly can, especially for tasks involving huge models and data sets.
Uh,
Their unique architecture minimizes those data movement bottlenecks, leading to impressive benchmarks, particularly in areas like conversational AI, which demands quick processing of complex language models.
So Cerebras is king when it comes to handling the really big stuff. But what about Groq? Where do they shine?
Groq excels at speed and efficiency, specifically for natural language processing. They prioritize predictable performance and low latency, which is critical for real-time applications like voice assistants.
Okay, so we're starting to get a clearer picture of how these chips compare.
Yeah.
But Schnepphat also dives into some of the design challenges behind these architectures. Let's unpack those a bit. What are some of the hurdles that companies like Nvidia Cerebras and Groq are facing when trying to build these next-generation AI chips?
One of the biggest challenges is designing the core architecture itself.
Okay.
It's not just about cramming in as many transistors as possible anymore. It's about finding the right balance of processing power efficiency and cost.
So it's getting more and more difficult to just rely on traditional methods to boost performance they have to get creative with the core design itself.
Exactly. And that's where we see some really interesting approaches. Cerebras, for instance, has opted for a design with smaller, more efficient cores that are specifically optimized for AI calculations.
Interesting.
This dynamic sparsity, as Schnepphat calls it, allows them to achieve high performance without wasting energy on unnecessary computations.
It sounds like they're mimicking the way our own brains work.
Yeah.
Where not all neurons are firing at once, only the essential parts are active at any given time.
Yeah. That's a great analogy. And this approach allows them to pack an incredible number of cores onto their wafer scale chips, which is crucial for handling those massive AI models. Now, on the other hand, Nvidia, with its more general-purpose architecture, has had to develop clever techniques to optimize performance.
Okay.
Schnepphat mentions their shader execution reordering, or SER, as a key example.
Okay, SER, I remember seeing that term in the essay. Can you break that down for us non-engineers out there?
Sure.
What's the basic idea?
Think of it this way. Even with a powerful GPU, you can still run into traffic jams when multiple processing threads are trying to access the same data simultaneously. SER is like a traffic management system inside the chip, analyzing the code and reordering instructions to minimize these conflicts, allowing computations to flow smoothly and efficiently.
So even with a powerful engine, you still need a good traffic system to get where you're going quickly. That's a great way to visualize it.
It is, and this kind of optimization is vital for complex AI workloads where every bit of performance can make a difference. But let's not forget about scalability. As AI models continue to grow in complexity, we need chips that can handle those increasingly large workloads.
So how are companies approaching this challenge?
Yeah.
Is it just a matter of making bigger chips?
Well, Cerebras has certainly taken that route with their wafer scale design,
Okay.
but there are other approaches too. Memory management, for example, is a major bottleneck.
Okay.
As AI models grow, they require vast amounts of data to be stored and accessed quickly, and traditional memory architectures can struggle to keep up.
So it's like having a giant library, but a slow librarian. You might have all the information you need, but it takes forever to find it.
Exactly, and that's why chip designers are exploring new memory architectures.
Okay.
Cerebras, with their integrated memory design, tries to eliminate this bottleneck by giving each core its own dedicated memory, reducing the need to move data around and leading to significant performance gains.
It sounds like a very elegant solution, but I imagine memory management is still a complex problem even with these new approaches.
It absolutely is. It's not just about the hardware. It's also about how developers write their code to make efficient use of the available memory.
Right.
It's a delicate dance between hardware and software optimization.
This has been incredibly insightful, but before we go any further, I think we need to take a break and give our listeners some time to digest all this. We'll be back soon to continue our exploration of the fascinating world of AI chips.
Sounds good.
We'll be right back after this break with part 2.
Looking forward to it. So, algorithmic efficiency.
Okay.
As AI models become more complex, we need to make sure the algorithms themselves are optimized for the specific hardware they're running on.
So it's not just about building faster chips,
Right.
but also about making sure the software is running as efficiently as possible on that hardware.
Exactly.
Kind of like making sure your race car driver knows the best route for the track.
That's a great way to put it. Nvidia, for example, has developed techniques like shader execution reordering, which we discussed earlier, to optimize how calculations are performed on their GPUs, making sure those processing threads are working together smoothly.
It's fascinating how much collaboration is needed between the hardware and software sides.
Yeah.
It's like a constant dance between the chip designers and the software engineers.
It really is. And this is where Groq's software-first approach becomes particularly interesting.
Okay.
By designing their chips with a specific set of algorithms in mind, they're able to achieve a level of optimization that wouldn't be possible with a more general-purpose chip.
So Groq is building their chips with a specific end goal in mind, rather than trying to be a jack of all trades. It's a different philosophy, but it seems to be working well for them in the area of language processing.
Exactly. And this focus on specialization is likely to become even more important as AI continues to evolve.
Okay.
We might see more and more companies creating chips tailored to very specific tasks like image recognition or robotics rather than trying to do everything.
That makes sense. It's about playing to your strengths. Now, Schneeplatt also touches on the competitive landscape in his essay.
Yeah.
Nvidia might be the big name right now, but they're certainly not alone in this game.
Mm-hmm.
Who are some of the other players vying for a piece of the AI chip pie?
Well, AMD and Intel are two major contenders.
Yeah.
They've been investing heavily in research and development to catch up to NVIDIA's performance.
So what are they doing differently? How are they trying to challenge NVIDIA's dominance?
They're each taking different approaches. AMD, for instance, has been making inroads in the data center market with their EPYC CPUs, which are designed for high-performance computing, including AI workloads.
Okay.
They're also focusing on integrating CPU and GPU capabilities onto a single chip, offering a more versatile solution.
So they're trying to appeal to a wider range of users who need both processing power and graphics capabilities.
Yeah.
It's like offering a Swiss Army knife of computing power.
Exactly. And Intel, after acquiring Habana Labs, is focusing on dedicated AI accelerators. These are specialized chips designed specifically for training and running AI models, and they're positioning themselves as a strong competitor to NVIDIA in those areas.
So it's a three-way race at the top.
Mm-hmm.
What do you think will determine who comes out ahead in the long run?
Well, continuous innovation is going to be key. Companies that can't keep pushing the boundaries of performance and efficiency will quickly fall behind.
Okay.
It's a fast-paced industry, and there's no room for complacency.
It sounds like a high-stakes game with the future of AI hanging in the balance.
Yeah.
But it's also incredibly exciting to see these companies pushing the limits of what's possible.
Absolutely. And for our listener, it's important to remember that this competition ultimately benefits everyone.
Okay.
As these companies strive to outdo each other, it leads to better products, lower prices, and ultimately more powerful and accessible AI for all.
Well said. This deep dive has been incredibly informative. I feel like we've only just scratched the surface of this complex and fascinating world of AI chips.
Yeah, it's true. There's always more to explore. But hopefully this conversation based on Jörg-Owe essay has given our listener a good foundation for understanding the key players, the challenges, and the incredible potential of this field.
And with that, let's move on to our final thoughts. What are some key takeaways you'd like our listener to consider as they continue their own exploration of AI chips? So as we wrap up this deep dive into specialized AI chips, what are some key takeaways you'd like our listener to consider? What's the big picture here?
Well, I think the biggest takeaway from Jörg-Owe's essay is that the world of AI chips is in constant flux. We've got established giants like Nvidia being challenged by innovative companies like Cerebras and Groq, and the landscape is constantly shifting.
It's like watching an ecosystem evolve in real time, with each company vying for its niche and pushing the boundaries of what's possible.
Exactly. And for our listener, this means that the choices we make today about which architectures to support and invest in will have a huge impact on the future of AI. It's not just about the chips themselves, but about the entire ecosystem of software tools and applications that are built around them.
So it's a call to action for anyone interested in AI to really pay attention to these developments and think critically about the long-term implications. What are some specific trends or areas you'd suggest our listener keep an eye on?
One important trend is the increasing specialization of AI chips. We've already seen this with Groq's focus on natural language processing, but I think we'll see even more chips designed for highly specific tasks like computer vision robotics or even drug discovery.
So instead of trying to be a jack of all trades, these chips will become masters of one. Does that mean we'll end up with a much more diverse ecosystem of AI hardware?
I think that's a very likely outcome. This specialization will allow for greater efficiency and performance as chips can be optimized for the unique demands of each application. It's like having a toolbox full of specialized tools, each perfectly suited to its task.
That makes a lot of sense. And what about the software side of things? How will that evolve alongside these specialized chips?
Software and algorithms are becoming even more crucial. We can't just rely on faster hardware alone. We need smarter software that can fully exploit the capabilities of these specialized chips.
So it's a symbiotic relationship. The hardware pushes the software forward, and the software, in turn, unlocks the full potential of the hardware.
Precisely. And the companies that can create this seamless integration of hardware, software, and development tools will be the ones leading the charge in AI innovation.
This has been a fascinating exploration of the world of specialized AI chips. We've learned about the different approaches taken by companies like Nvidia, Cerebras, and Groq, and the unique challenges they face in pushing the limits of AI hardware.
And we've seen how these advancements are shaping the future of artificial intelligence, driving us toward a world where AI becomes even more powerful, versatile, and integrated into our lives.
It's a future full of possibilities, and thanks to Jörg-Owe's insights, our listener is now better equipped to navigate this exciting landscape and make informed choices about their own AI journey.
Absolutely. And remember, the most important thing is to stay curious, keep learning, and never stop exploring the ever-evolving world of artificial intelligence.
That's great advice. And with that, we'll wrap up our deep dive. We hope you've enjoyed this insightful exploration, and we encourage you to continue your own research and discovery until next time.